All right, so now I want to look at adding and multiplying polynomials. Okay, this is the heart and soul of the lesson, and you'll find it's not terribly long or complicated. And it's probably things you've done before. So let's talk about how you add two polynomials together. Now we know what a polynomial is. It's any function where I have a bunch of things with x to positive whole number powers and numbers in front of them, and they're added all together. So 2x squared minus 3x plus 1. Polynomial, polynomial, polynomial. Add them together, you get a polynomial. Polynomial, polynomial, polynomial. Add them together, you get a polynomial. So one neat thing about polynomials is as we add, I'm going to put it in the screen shade so you don't get overwhelmed. As we add two polynomials together, the sum of two polynomials is always a polynomial. Pretty neat. Okay, so just like if I add two numbers together, I get a number. Same thing with polynomials. Add two polynomials, you don't get something else, you always get back a polynomial. Okay, so let's figure out how we're going to add this function to this function. We're going to do what we always do. We're going to combine like terms. So all I've done here is written out 2x squared minus 3x plus 1 and 4x to the fourth minus 3x squared minus x. So I've just rewritten these together on the same line. I combine like terms, which means that I group all the x's of the same power together. So how many x to the fourths do I have? I have 4 here and no more. So all I'm left with is 4x to the fourths. How many x squareds do I have? Well, I have 2x squareds here and negative 3x squareds here. So I have 2x squared minus 3x squared. How many x's do I have? I have a negative 3x here and a negative x here. So I'm going to group those together, combining like terms. And I just have a plain old negative 1 and no other constants. It's right here. So I have 4x to the fourths. I had 2x squared minus 3x squared. So that leaves me with negative 1x squared. I had negative 3x's and then 1 less x. So negative 3x minus x is negative 4x. And the 1 is just hanging out here by itself. So the sum of these two polynomials is 4x to the fourth minus x squared minus 4x minus 1. Okay, here's just a note I want to point out here. For the purposes of addition, okay, we can treat each power of x as a separate variable. This only works for addition. That's to say that we add up all the x squareds together. How many x squareds are there? We add up all the x cubes. We add up all the x to the fourth. We add up all the plain old x's. We add up all the constants. Okay, and we look at those as their own variables, so to speak. Look, here I said, how many x to the fourth do I have? I had 4 of them. I added them together. How many x? I didn't have any x cubed, so I didn't have to look at that. How many x squareds did I have? I had 2 here and negative 3 here. I combined those together. When we're talking about addition, we never combine different powers of x. Now this is only true for addition. We will combine different powers of x for multiplication, but not for addition. So that's just an important factor to remember. And it makes our addition not so bad. If we think about it like, how many of the x squareds do I have? I have 2 here, and I have negative 3 here. How many x's do I have? I have negative 3 of them here, and negative 1 of them here. Okay, and that's how we add polynomials. We'll do some practice in class, don't worry. Okay, let's talk about multiplying polynomials. Now, this, as you can imagine, multiplication does get a little more complicated than addition sometimes. That's okay. Don't worry about it. We're going to be fine. So, multiplying. Well, this looks a little bit like foiling, and it is a little bit like foiling. I have a polynomial, x plus 2. That's a polynomial. It's a line. And I have another polynomial, 3x squared minus x minus 5. This is a quadratic. So I'm multiplying a linear function by a quadratic function. Now, foiling basically works here. First, outside, inside, last, except that over here I have a first, a middle, and a last. So I have to be a little bit different. Here's the rule. Okay, and this is kind of an informal rule, so you know, it may not be foolproof in terms of the grammar, or in terms of the meaning, I should say. The rule is we're going to multiply every term by every other term in the other set of parentheses. What that means is that x will get multiplied by everything in here, and 2 will get multiplied by everything in here. I'm going to get every possible combination of x and stuff in here, and every possible combination of 2 and stuff in here. That's how we multiply. So, x must be multiplied by 3x squared, by negative x, and by negative 5. Okay? 2 must also be multiplied by 3x squared, by negative x, and by negative 5. So here's what we end up with. So I multiply x by 3x squared, x by negative x by negative 5, and 2 by 3x squared, 2 by 3x squared, 2 by negative x, this should be 2 by negative x, and 2 by negative 5. Okay, and now we multiply and combine like terms. X times 3x squared, well, I have x times 3 times x times x, that's 3x squared. This is x times negative x, that's negative x squared. This is negative 5 times x, well, that's just negative 5x. This is 2 times 3 times x, that's 6x squared. This is 2 times negative x, that's negative 2x. And this is 2 times negative 5, that's negative 10. Okay, so I'm just multiplying out. Once I've done the first multiplying step in terms of distributing, this is a distributive step here, now I've actually done the multiplying step. Now again, just like with addition, I combine like terms. How many x cubes do I have? I only have 3. How many x squareds? Well, I have a negative 1x squared here and a 6x squared here, so I'm going to have 5x squareds. I've got negative 5x's, and I've got negative 2x's, so that will leave with negative 7x's. I've got a negative 10. There it is. Oh, this should be a 5x squared. Okay. All right, let's look at another example, and this will be it. Okay, xy minus 4 cubed. Now, whenever you have cubed, what it really is the thing by itself 3 times. So I'm going to rewrite it, okay? There are shortcuts, definitely, but let's go ahead and rewrite it because the shortcuts are easy to forget, but these always work. So this is what it is. 3 things multiplied by each other. One thing you need to remember about multiplication is it only works pairwise. That's to say, if I have 3 times 4 times 5, okay, at the end of the day, I'm going to multiply all 3 together. But at any particular instance, I can only multiply 3 times 4, take that product, and multiply it by 5, right? Or I can choose to multiply a different pair first. It doesn't matter which pair I choose to multiply together first with multiplication. But I have to think about the fact that I do 2 at a time, right? And that's it. So what I'm going to choose to do in this case, it doesn't matter really because they're all the same, I'm going to choose to multiply the first 2 together and look at that as a separate problem. Once I've solved that problem, I'm going to multiply the result by this thing out here. Okay, so here's what I did. I multiplied this out, and all I did was FOIL. So if I FOIL, I get firsts, xy times xy right here, outsides, which is xy times negative 4 right there, insides, negative 4 times xy, and last, negative 4 times negative 4 is positive 16. Okay. And remember, this thing is just still hanging out. I said I'm not going to deal with this until I'm totally done with the first part. So I'm going to simplify it. Xy times xy is, there are 2 x's and 2 y's, so x squared y squared. I have negative 4 xy's, another negative 4 xy's, that's a total of negative 8 xy's, and then the 16. So now I've solved the xy minus 4 times xy minus 4. That happens to be x squared y squared minus 8xy plus 16. And I've still got this thing hanging out here. Good. So part 1 of the problem is done. Now I have to multiply in this last binomial. This is called a binomial. Okay, this is the same concept as I had in the previous problem, where I take every possible combination of this and stuff in here, and this and stuff in here. Okay, so I have to look for all the possible combinations. All right, I can do the same thing. I can take this times this, all the possible combinations of this and these, all the possible combinations of this and these, all the possible combinations of this and these. I'm going to get the same combinations at the end of the day, no matter which way I look at it. So, x squared y squared times xy, that's the first part right here. Then I'm going to take x squared y squared times negative 4. So all the combinations of x squared y squared and the stuff in here. Boom. Okay. I don't want to cross that out. Now I get negative xy times all the combinations in here again. Negative xy times xy, that's right here. Negative xy times negative 4, that's right here. Okay, good. Now I take 16 times all the combinations times all the possibilities in here. 16 times xy and 16 times negative 4. Okay. Oh, I'm missing one. 16 times negative 4 is there, but I need my 16 times xy. Ooh, I'm glad that I caught that. Okay. Now, this simplifies. There are x to the second, y to the second, x to the first, y to the first. I can combine those to x to the third, y to the third. These two simplify to negative 4x squared y squared. That's easy enough. These two here simplify to negative 8x squared y squared because I have an x, a y, and they're all multiplied together. These two simplify to positive, pardon me, because I have a negative and a negative, positive 16xy. These two simplify to negative 64, and because I forgot it in the previous line, I also have my 16xy hanging out. Good. Now I'm almost done. I'm going to combine all like terms. My only x cubed y cubed is right here. I only have one of them. Okay, how many x squared y squareds do I have? I have negative 4x squared y squareds here, and I have negative 8x squared y squareds here. That's a total of negative 12x squared y squareds. I've got a 16xy here, and I've got a 16xy here. Because I made that mistake earlier on, this becomes 32xy. 16 plus 16 is 32, and I still have my negative 64 hanging out at the end. Okay? So, my solution is, if I take xy minus 4 cubed, I'm going to end up with x cubed y cubed minus 12x squared y squared plus 32xy minus 64. Boom, we're done. Okay? And that's it for today. Thanks, guys.